right. Well, so I will get your exam graded as soon as possible, sometime probably in the next couple of days, and then I'll post grades and feedback. And I try to give you feedback in the comments section. I've discovered that some people aren't looking at the comments. They're just picking up the grades. So maybe you have to go somewhere different in Canvas from where you're used to. But if you lose any points, certainly there will be information about which question, and at least a few words about the issue there. I'm not going to talk about the exam yet because there's still some people taking it. But Tuesday we will definitely go through the whole exam, and we can talk about whatever questions people have and so on and so forth. And so, any questions on other things, like PA4, for example?
Do you ever have any issues in the design window of your system freezing up?
Sometimes. So, the current version of Window Builder seems to work pretty well, but in the past, there have been times when Window Builder will freeze, and usually if it's a bug, what happens is it throws some kind of exception, and it says something horrifying on the screen about, cannot parse or something like that, and there's a retry button. And if you hit retry, it will try again, and sometimes you have to retry like several times for it to work. But if it's completely hanging, it might actually be something different. It might be something in your code. And so if it started after you changed something in one of your methods or added something to an event handler maybe, or something in the paint method, double check your code. Because basically it's running your code in order to draw that window you see in the design tab. And if there's something weird in there, if there's an infinite loop or something like that, it'll actually hang when it tries to display the drag and drop window for you.
Okay. Yeah, it was more like I was trying to add a label,
Mm-hmm.
and I tried about 6 times, and then on the seventh time it actually worked.
Oh,
Because I would
interesting.
click on J label, and I wouldn't even get it over into the window yet, and it would just freeze the whole thing and say it's not responding.
Okay. Well, that's
But it,
bizarre, but I've also seen things like that. And I'm guessing there's ways that people who do this for a living get around these issues. Um, I'm not one of those people, I guess. Um, but let me go ahead and share my screen.
I actually do have a quick question pertaining to the PA4.
Yeah.
As far as the event handling for the start button, I got the start button perfectly fine, but if I do restart, it doesn't run the same code. Like, it doesn't go back through that same event. Do you have to do like an override method or something for that? Or should
No,
it should go back through?
it should go back. Are you using two buttons or one button?
I have a stop button, which
Mm-hmm.
is like kind of resets the board and everything.
Okay.
But then when I hit restart to start it again, it just like everything just kind of like it starts again, but it's not. I don't know. I guess it's not like picking up. If I put new names in, it won't pick up stuff like that.
Okay. Yeah, as long as you've got the event handler tied to run your code, it should reliably run whatever code you're putting in the handler. But it's very possible. It's very easy to have something that needs to be reinitialized that might be happening prior to the start button. And so the first time that you run this and you say start, it works great. But then when you try to restart, you forget that, oh, I also need to go back and do a get text on these text fields and store it in some string or something like that. So it
Okay.
could be a
Yeah.
code issue.
I'm thinking I need to add my reset method into the beginning of the start.
Right, right.
Okay.
And so yeah, the other slightly flaky thing I see sometimes with Window Builder. So if I left click on a J button, I can move my mouse and drop it in here. And then sometimes when I go back to left click it, it will not take the second time. But it's usually pretty clear when that's going on. Because you move your mouse in here and nothing is moving with it. But it seems to be behaving well right now.
Yeah, I wonder if maybe because, like you said, I have a lot of code and a lot of elements that maybe it's just not running efficiently or something.
Mm-hmm.
But I have everything, luckily, in there now that I think I'm going to put in. I just wanted to put like a statement that said whose turn it is, so you can tell when you're playing.
Mm-hmm. Right.
And that was like the last element that I wanted to add, and of course I took me so long just to do something easy.
That's usually how it works, right? Let me see if I can break Window Builder. No, that's working pretty well. Well, let's see. So if I mess something up in here, I can certainly hobble my paint window. And even though I'm just trying to display a JPanel, it's actually going through the source code. And in this case, I've taken out a JPanel, so all of these things are syntax errors now. And so when I go to the design window, it's just trying to sort of execute that that main method, and it can't do it because it can't compile it. So I get sort of my JFrame, but I don't have my other stuff, my buttons and so on and so forth.
Here's another question. So, say like when someone wins the game, right, and all the boxes are taken up.
Mm-hmm.
I have a general idea how to look for that, but is there a way to basically like push the stop button for them, or do an action that you already have, like call that action?
Good question. So that's something that fairly frequently we find ourselves wanting to do. For example, if you had a reset button, right, you might want to just click that at the end of the game to reset the whole game. You don't really want to try to call that event, but what you can do is, inside the button handler, instead of putting a bunch of code in here, just make a call to a method. And put all of the stuff you want to do in here inside a separate method, and then you can call that separate method somewhere else, and it'll basically do the same thing as if the button was pressed.
See, you said you don't have to be clever.
Clever is relative. Yeah, we're definitely getting into clever things.
Yeah, that'll actually work very nicely.
Cool. I guess what I meant by not being clever is that a lot of the code is sort of the same stuff over and over and over and over again. It's like do these calculations 4 times and then do these calculations 4 times and then write 4 if statements and so on. And once you know how to do, one of those, it's an exercise in typing and changing your x's to y's and not messing up. And if you have one y that is accidentally an x because you forgot to change it, you won't get a compile error, you won't get a runtime error, but you'll get lots of weird behavior, and that can be. Did that happen? Yeah.
I was trying to. So I originally set up as row column.
Mm-hmm.
Or rather, sorry, column row.
Oh, okay.
What you had on your grid
Mm-hmm.
thing. And I was getting a weird behavior, and so I finally figured out what the issue was there. And then I was like, oh no, he wanted row column, and so I switched it. And I was getting the same behavior that I had experienced before, where I was clicking in one box on the edge, mark 2 other lines.
Right.
Oh man, that was a pain to debug.
Yeah, I can imagine, and a lot of these things I've actually encountered when I first coded this up. And it can get weird, you know. You click in one box and the line appears on the other side of the board, and it's like, what the heck? And it's, you know, yeah.
I had done the same thing where I flipped the X and Y around a little bit.
Mm-hmm.
So I was doing my checking and I'd click in one row like on the left and it would draw like 2 rows over on the other side on the right.
Right.
Like, what the heck is going on?
Yeah, that's fun. And I mean, it's just code. It's just doing what you tell it to do. But it's a really interesting exercise in you know, it's like playing gossip or telephone, where you like the message changes over time. Well, sometimes just going from what you want to telling the compiler something changes, and you know, this kind of program in particular, you can get pretty visibly bizarre results. The other side of that, though, is when it works, it feels pretty clear usually that it's working. I mean, you start clicking around and you see lines drawing, and you start to feel very confident that this is going to do, you know, the right thing every time that you do this, and that feels really good. That's the kind of drug of programming that keeps people programming, right? Is making these things happen predictably again and again and again. So that's pretty fun.
Actually, I do have another question too.
Go for it.
Taking up everybody else's time. In the constructor where you have like the J labels and the frames and all that stuff,
Mm-hmm.
that's kind of the only spot I'm able to call my labels to like reset the text. Is there a way to set that up where I could use it outside?
Sure.
Like, is it just using like a global or something like that?
Yeah. So for example, we've got this tab here. Suppose I want to change this label when I hit the clear button, right? So this label is called label name. And if I come in here, I could say something like label name dot set text. And if you're lucky, that will just work automatically. But we're not always that lucky. But in this case, you know, that seems to work. But some of the things that can get weird from there, right? So one thing is label name, depending on where it's declared, may or may not be accessible. For example, right here, label name is declared at this point, and if it's telling you that it doesn't know what label name is, just do something like this. Right, change this to just a construction, and then in the beginning of the class, I need to change my key bindings here. In the beginning of the class, go ahead and declare your variable. And so you can leave the constructor in the same place, but then once you put this declaration up here, you have access to it everywhere. But it may happen that you need to, for some reason, access that label from a different class, like say from Super Cool Panel. And if we wanted to do that, then we gotta get a little trickier. And so this is another area where the keyword this can come in. I don't think you necessarily need this for PA4. We will see it in PA5. But suppose I wanted to, let's see what we got. Suppose I put a button, well, let's see. Let's not get too weird. All right. So I've got a draw rectangle, and I'm printing something out to standard out, my list.length. Suppose I want to have a message box. So we're going to put a message box in here. We're going to try to write to it from our paint method, right? Or our add method, where we're adding things. So we want to link these classes together. So let me go ahead and just drop a text field in here. And let me call this message box. And what I'd like to do is inside here, instead of printing this out, I'd like to say messagebox.setText and display the list length inside this this little box right here. All right, now I can't do that right now because MessageBox is not defined inside SuperCoolPanel, right? MessageBox is defined inside my main class. So there's where MessageBox is set up. So a couple of things I'm going to do here, right? I'm going to change this to public so that it's accessible from a different class. But how am I going to tell SuperCoolPanel how to get to that message box? And there's a few options, but here's a way we can do it using the this keyword. So I'm going to construct a SuperCoolPanel right here. And I'm going to pass, I'm just going to make a method in here. So I'm going to say my board save parent this. So I'm going to tell the SuperCoolPanel who its parent is. And then in SuperCoolPanel, if I want to get to something in this parent class, like the message box, I'll be able to say, you know, parent.messageBox. So I'm going to pass my identity, you know, my who I am, to a method inside the SuperCoolPanel. So to write this method, I'm just going to make a new method here. So record who our parent is, so public void save parent. And the thing that we're passed is an object of type, well, type all of this stuff, right? And what is all of this stuff? It's a class main. And so the argument to save parent will be an object of type main. So we're going to say main parent. And I'm going to save parent in a variable in this class called rParent. Well, I guess I can, my parent. And up here in the beginning of SuperCoolPanel, I'll say main my parent. All right, and all of this is so that down here, when I do this message box, I can actually identify message box as belonging to my parent. All right, so let's run this, and then we'll step back and look at what we have. I have a error here. Message box is a method. Nope. Message box.
And did you save main?
I have to save main, yeah, thank you. Alright, so if we run this, this should work, and in this window, up this text field up here, we should see what the list length is. And you can see it's incrementing up to 50, and when we clear it, it goes back to 0. Alright, so what have we done here? I mean, we could have done this in more simple ways, but what we've done is we've got an object in the main class, which is, you know, the JFrame, so a lot of the pieces of our game are going to be on the JFrame, but we can interact with these from inside methods that are associated with this other class, a my panel or a super cool panel. And so how do we do that? When we construct the super cool panel, we tell it who the JFrame is. We pass it the identity of the JFrame, or in this case, a thing called a main, by just passing it to a method. And then inside that super cool panel, we have a save parent method, and the whole purpose of save parent is to take an argument of type main and just save it in this variable called myParent, which is an object of type main. And then when we want to get to a field inside that JFrame, that parent class, we can say myParent dot, and we could access, any object or method in that main class that we have access to. So this is how, the sort of created class, the JPanel, can interact with the frame. The other direction is straightforward, though, because the frame is creating the super cool panel. So if the frame wants to do something with the super cool panel, it already has access to it through myBoard. So it can say myBoard dot, draw a rectangle, and so on and so forth. So that lets you connect these things in both directions. And usually it's not going to show up for this program because most of our buttons and text fields and so on are going to be up here. And this panel down here is really just going to be for a paint method and to pick up mouse actions. But you can do two-way communication like that. So that was all linking the JPanel and frame.
I think I wrote a method in my main program, or excuse me, I wrote a method in my game board program or class, and called it in my main program and passed the parameters that I need over.
Okay, cool.
And was able to save it to a local variable in that class.
Cool. Yeah, that should work too.
Mainly for the paint method to get the correct initial in the box.
Ah, okay. And there again, if you want, right, you can store the initials inside the box objects and have paint just read them from each box as it goes through the two-dimensional array. And then in the mouse handling code, when you find a box has been completed, you grab the initial and store that in the box object.
It's funny. Now that you say that, I could probably delete all of this stuff because I actually am doing that, but I'm not using that in my
okay.
my paint method.
Okay.
Might revamp that real quick.
Yeah, either way is fine. It's very common to finish a project or come close to finishing a project and then want to kind of like make major changes to it. That's fine, and sometimes we do that, sometimes we don't. I've dug into some code that I wrote about 10-15 years ago recently, and oh my gosh, it is a nightmare. It was before I was teaching Java, and so I had a very different way of doing Java, and it was pretty horrifying. And if I had the stomach, I would go in and revamp it all, but I don't think I do, so I've kind of consigned it to code that will slowly lose its ability to be run over time. But,
It's funny looking back at all the things you could make easier.
Yeah. And cleaner, And I've got code that is breaking as Java goes through new revisions. And now with Java 17, there's things that I used to do that just don't work anymore, right? Because I wasn't following best practice at the time, and then, changes to the language.
At work this morning, I was trying to get rid of some pretty horrid code myself, and trying to basically take code that gets sent from a server backend and essentially formats an HTML script with what is essentially a glorified preprocessor for C.
Ah, cool.
And I would literally inject that preprocessor stuff all over the JavaScript.
Ooh.
I'm trying to make it much better and just fire off a JSON from an HTTP request.
Mm-hmm.
So.
Yeah. And anytime you're getting into, you know, sort of creating processes and interacting from one process to another, that's a whole nother ball of wax. And we'll get to that probably next week, actually. And that's fun stuff. All right. So as far as I know, I believe that the last lecture of the quarter, which will be June 9th, I'm going to cut that an hour short. And I know that's very disappointing because you want to stay in class as long as possible that last day. But I'm on a hiring committee and I need to do something associated with that, and it's scheduled for 2 o'clock on the 9th, and it's already been pushed back once. And if it doesn't happen then, it won't happen until September, and this is for a pretty important position. So I'm probably going to cut that last class short by an hour. And I will do an extra hour of office hours later that day, just in case, you know, somebody or people wanted to go over code or ask questions or something like that. So I'll announce that, you know, closer to that last week, and let you know for sure if that's happening. That's just kind of an early heads up. And I don't know if they're doing spring thing this year. Does anybody know? Does anybody know what spring thing is?
Nope.
Maybe they're not doing it. So usually, like the last Thursday, I thought it was of the quarter, they would do this big outdoor party, right? They'd have tons of free food, and they'd bring in like rides, and there's a climbing wall, and there's all sorts of stuff, slip and slides and stuff like that. And if you're lucky, you know, it's like really warm out, and it's just kind of like an all afternoon party to kind of celebrate the end of the year. And I don't know if they're doing that this year. I mean, they didn't do it last year because of COVID. I'm guessing maybe they're not doing it this year either, because I haven't heard about it. But if that happens to be going on Thursday, you get an extra hour to do that if you're on campus. So there's the upside.
Running around, I got it.
Yeah. All right. Let's see. Any other questions?
PA5 is the last assignment, yeah?
That's correct. Yeah.
Are we just going to be modifying the code base for PA4 if it is like a network version with sockets and whatnot?
Yeah, exactly. PA5 is going to be a networked version of PA4. So as long as you're writing PA4 in a way that's not too kind of cobbled together, it's really just adding another layer on top, so that when you click a mouse, it does what it does now, but it also sends information to the other side saying, hey, this person clicked a mouse at these XY coordinates, and then their game updates the board accordingly. Both games switch to the other player, and you go into waiting for, instead of a mouse click from your mouse, you wait for a message from the other side of the connection saying, hey, the other player clicked a mouse. And then you both do the same thing, and you go on from there.
Cool.
And so we're going to talk about... Go ahead.
Not to jump too far ahead, but we're going to be doing this with like raw threads and not async co8 stuff, right?
Yeah.
Gotcha.
Yeah, so we're going to talk about threads probably next week, which is a way to do multiprocessing in Java, to have, you know, 2 or more things happening simultaneously if you have multi-cores, or, you know, pseudo-simultaneously if you're on a single core. But basically to have 2 different execution contexts going at the same time. And we'll take that as a topic on its own while people are finishing PA4. And we'll look at all the different ins and outs of you know, pitfalls with multiprocessing, and, you know, the things we're hoping for as far as performance improvement and so on. and thread safety and deadlock and live lock and so on. And we'll play around with that, and then we'll talk about networking. And networking in Java is pretty delightful. It's a few lines of code to set up a networked connection, and then it's basically like, you know, reading from a file or writing to a file, but instead of it being a file, it's actually a connection on another machine. And if another machine writes into this socket, we can read from the socket and see what was written, and we can set up a two-way connection like that, and it's a pretty painless way to do networking. Yeah, race conditions and deadlocks can be very painful to debug. Your best policy is just not to create those conditions in the first place. And if you figure out how to do that, let me know, because it's really hard. But there's some things we can do. And if we know that there's an area where, you know, there could be a race between two processes and such, right? It's very easy to synchronize in Java. There's a couple of keywords we can use to control exclusive access to objects and methods and so on. And it's pretty nice compared to, you know, what you'll do probably next year in C in a system programming course.
Yeah, it's honestly one of those few spots where there really is a legitimate argument against object-oriented because of, you know, if 9 people have the key to one piece of memory, who has the key if somebody halts?
Right. Yeah, and it can get, you know, arbitrarily complex. And clearly, you know, there are situations where even people who are, you know, very skilled professionals working with these things make mistakes, right? Because systems hang sometimes. Servers need to be rebooted sometimes. But we can do a job of catching most of the potential issues, and for what we're doing for PA5, we're not really going to get too sketchy. PA5 is going to be very much two ends of a connection moving in tandem with one another, and that's going to simplify how our threads will interact with one another. We're going to know if we're waiting for a mouse event or we're waiting for a message from a socket. And if one thread is waiting for a mouse and another thread is waiting for a socket, they're going to know, you know, whose turn it is to take some action. And so it's not too bad for PA5. But in general, it's can be a pretty hairy area of coding. But that's kind of fun too. All right. Well, I didn't want to, you know, start something totally brand new today, because it's a Thursday and because, you know, maybe we're a little brain dead from taking exams, or, you know, in my case, from grading exams. So I wanted to go through sample code for PA3, and just kind of show you that, not because it's, you know, better or worse than other code, but just as you know, a different version of how PA3 can be coded, possibly different from how you might have done it, or how you might have thought about it. Possibly, you know, very, very similar to what you did, but I just thought, you know, so I coded this myself, so I share some of your pain with 20 questions. But I did have a lot of this coded before. I just cleaned it up. All right, so I broke my my project into 3 pieces. So PA3 is the main class, and then there's tree, which is the tree itself, the decision tree, and it's largely a wrapper around the node class, which is, you know, the individual nodes. And so things like traversing, you know, there's the usual dual structure where you call the traverse method in the tree, and that calls the traverse method on the root. And so this sort of dual implementation we saw when we did a sample binary search tree, that persists here as well. So PA3, I set up a default database for 20Q. Oh, so I don't know if I talked about it, but yeah, I probably talked about it. Most of the PA3s looked great. Most of the point losses were pretty minor things, like not having a default database, right? So some of the submissions, if you didn't specify an argument, it gave you an error or it threw an exception. But part of the problem was, you know, if you run this with no arguments, it should use 20q.txt. So here I'm setting that up as a default database, and if you specify a command line argument, so if this array has length 1, then I change database to whatever that first argument is. So that takes care of you know, the two ways to run the program. And then my tree class has a single constructor which takes the name of a database file and returns a tree. And so inside that constructor, I do all of the work of ingesting from that file. And I said you can assume the file is perfect, so you don't have to worry about, you know, a truncated file, a corrupt file, and so on. So this tree that I get back should never be null, but I threw a check in here anyway to see if the root is null, and if it is, it means something went wrong when trying to read the file. But you don't need that. All right, so this one line opens the file, pulls it in, reads it in node left right order, closes it when it's done, and leaves me a decision tree, in this case called T. So I can go ahead and print a welcome message, and then I just go into a while forever loop. And T has a method called play a game, and that basically starts from the root, moves down the tree, goes left right based on answers to questions until it gets to a leaf. Ask the user if the final answer is correct. If it is, perfect. If it's not, then we do a little dialogue and we update the tree. So this version of play a game returns a boolean. It returns true if the tree has been modified. So here I have a statement, if t.playAgame is true, then let's go ahead and call the traverse method and write that traversal into this database file. So that handles playing the game, and also inside play a game the tree gets updated, and if that happened, then we go ahead and write it back in. And there's you know, a number of ways you can do this. You can make play a game a static method inside this class. You can do the writing of the tree inside play a game at the end. You could have a different method that, you know, comes back and tells you if you won the game or not, and if you didn't, then you could call a different method that does the dialogue to update the tree. So lots of ways you can organize this, right?
You could have tried one pattern that people like to try out do a lot is constructing a factory method for the tree.
Mm-hmm.
So like a single method to basically act as a glorified constructor that is going to build an object that's a little more complicated than just running a constructor on it.
Mm-hmm.
So like a tree, or you know, in my case at work we use a thing called an ORM, an object relational manager, which has a factory method called session, which builds a query from a database.
Cool.
Based on some objects you may have as models.
Okay, awesome. All right, so as usual, a pretty simple main program. I tend to opt for simpler main programs these days. It changes over time, but past few years I'm in this mode where I try to keep main pretty simple and do all the heavier work, you know, inside these things. So main workhorse is the constructor for tree and this play a game method, and then a little bit of work in the traverse method. So the tree class has a node called root, which is initialized to null, and so the tree is largely just a place to keep the root, right? And when I construct a tree, when I call something like, you know, construct this with database, the T that I get back here is just a tree whose root has been set to the root of that decision tree. All right, so here's the constructor, right? Open a scanner on that file name, and if anything goes wrong, print an error message I'm going to return. And when I return, the root will be null, and this will say, okay, let's go ahead and exit. But you could also exit from here. You can do a system.exit, parentheses, some integer, and just kick out at this point. But this handles, if you can't open the file. Otherwise, I call the read tree method, which is defined in here. I pass it the scanner that I constructed up here. And read tree is set up to return a root. And then I close the file, and that's the end of the constructor. So read tree is this thing that we sketched out on paper. It was sort of 3 sections, right? The first thing is read a line from the file, right? And if there's not another line in the file is corrupt, right? That should not happen because I said the file will not be corrupt. But if there's not another line sitting in the file, something's wrong with the file. It's probably truncated. So if I don't have a next line, I'm just going to print an error message, and I'm going to do a quick exit. This will take me out of my entire program. And you can just have faith that everything is there and ignore this completely. So what do we do? Read the next line of the file. That would be a Q or an A. I just check the first character, and if it's equal to an A, then this is a leaf node. It's an answer. So read the next line. That's the text of the answer. Save that in the text field of the node. Set the question flag to false to say this is an answer. Set the children to null, and then return that node. So if you call a read tree and the scanner is pointing at an answer, it just returns a single node, which is a leaf node. Otherwise, take the next line, save that in the text field, but set the question flag to true. And this means the scanner was pointing at a question. And then go ahead and do your recursive calls to read the yes tree and the sub tree, the no tree. So take the current line you're on, save that as the text, and then call read tree twice recursively, and that'll continue from wherever it is in the input file until it gets to the end of a tree. That'll be the yes, and then you do it again, it'll be the no. And if you started this from the beginning of the file, after this call you'll be at the end of the file. But if you're somewhere through and you were doing a recursive call, right, these calls will take you further down the file, but not all the way to the end. So we don't think about that too much, but this is basically a recursive node left-right ingest of a tree. It reverses the operation of writing something in pre-order. And then at the end we just return temp, which is this new node. And then traverse is mainly a wrapper, so we pass it a file name. We try to construct a print writer. If we fail, we'll just print an error message. Otherwise, as long as the tree is not null, call the root node's traverse method, and then close the print writer. And again, the root should never be null, so this is kind of optional. And then playing the game, open a scanner on standard in. Start at the root, ask the user to think of an object, and then so temp is our current node, as long as it's a question, ask the question, right, print out the text, and wait for an answer. So I wrote a getAnswer method that I pass at the scanner for standard in, and it'll return a Y or an N. And so if getAnswer is a Y, I'm going to set temp to the yes child, otherwise I'll set temp to the no child. And we just loop here until temp's not a question. That's when we hit a leaf. And once we're at a leaf node, we're done playing the game. Now we have to see how we did. So ask if our answer is correct. Get an answer if it's a Y. Then we guessed what they were thinking of. We can gloat a little and then return false, saying, hey, we did not update the tree, so you don't have to rewrite it. Otherwise, we go through this long, wordy dialogue of, okay, what were you thinking of? We save that in final answer. Give me a question which differentiates those. We save that in new question, new Q. And now we build a little 3-node tree. All right, have a good one. Build a little 3-node tree. So we make a new node on the yes side. Save the final answer, so that's the yes answer. Make it an answer, so it has no children. Make a new node for the no side, and that's got the answer that we guessed that was incorrect. Make that an answer node. and then in this case, I just changed the prior leaf node, which was temp, to be a question. Set its text to be the question that differentiates between the thing they were thinking of and the thing we guessed. And then I point the children to those two new answer nodes. And then say goodbye to the user and return true to say, hey, go ahead and write this tree out to the file. And then getAnswer is just a loop. Basically, pass it a scanner for system.in. Get the next line, and I didn't have to do this, but basically take the next line, add a space to it so that it's at least one character long, and then pick off that first character using char at. And that gives me a character, and I can see if that character is different from y and n. If it is, I'll ask them to try again, and I'll repeat that operation. When I come out of that loop, answer is a single character, which will be guaranteed to be either a y or an n. And if they type anything beginning with a y, it'll take it as a yes. And if they type anything beginning with an n, they'll take it as a no. And so I return that answer. And then the node class is nothing too complex, right? So it's got the fields for a node, so the string that holds the question or answer, a flag to tell me which it is, and a pair of children. I want to usually construct it by passing it the text field and the question flag, and so that's what this constructor does. But sometimes I want to construct it with no arguments. I'm going to set those fields up outside. So this is just a no argument constructor, and it doesn't do anything. But if I don't have that, I'll get compile errors. And then the main method in here is the node left right preorder traversal, which basically says print either a Q or an A, depending on whether this node is a question or an answer. So if it's a question, it prints Q, otherwise it's an A. And then follow that by a colon, a new line, and then the text of the message. So that prints those two pieces. And then if it's got a yes child, traverse that subtree, and if it's got a no child, traverse that subtree. And that's the preorder traversal. So that's just one example of a solution for this. But the submissions I saw, were all perfectly fine. A few details here and there. So any questions on that? All right, well, we got a few minutes left here, so let me go ahead and talk about something different. We talk about JavaDoc. And I closed Eclipse, didn't I? So JavaDoc is another Java utility that will create HTML pages for us that basically document our project. So let me go ahead and open one of our projects here. So let's do Painter, and we've talked about this a little, right? This is just a browser for our different projects. Basically, each of these is a different directory under whatever workspace you set up. And if you expand this, you'll see different subdirectories. We don't usually want to mess with this, right? This is where the Java library is. But if we expand source, we'll see our .java files under a default package. And so I can look at main, and I can look at my panel. And you can put comments in here and stuff, but there's extra things you can do when you comment Java code. And so a big part of this is, you can write comments by saying slash star, comment, 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 and then star slash, just like you do in C. If you begin a comment with slash and 2 stars and hit enter, you get a bunch of text filled in for you. And it's got a tag here, @author Nick, and it's sitting here waiting for me to type. And this is a way to tag your code with basically a markup language, right? It's a pretty simple language. But what I can do here, since this is a block of comments right before the class, I could put information in here about this class. So I could say, sample main class for working with swing with a typo. And author, well, it got the name Nick, I think, from my username on this machine, so I could change this to, Nick Macias or something like that. There's apparently some, controversy about why you should never use the author tag. It seems to be considered poor practice for some reason. I didn't have the patience to read through all of it, but it comes in by default here, so I'm just going to leave it there. But what we can do is we can document our classes like this. So let's do this one because we've actually got some stuff in here. So let me do a slash star star, and this is custom JPanel class that includes a way to paint a rectangle. That's a very boring comment. All right, so let's hit some of our methods here. So I have a method called saveX. So I'm going to say slash star star, and it's another comment block up here. This is where you write your few line description of what this method does. Let the caller save an X coordinate from a mouse click for later drawing inside paint. And it says it made this block @param space X, and what I can do here is I can tell you what X is. So this is the X coordinate of the mouse click. And if I come down to save Y, and I start a slash star star, it'll do the same thing. So I'm just going to copy this comment from up here and say let the caller save a Y coordinate, and param Y will be I'm too lazy to type. So this will be the Y coordinate of the mouse click. And let's go ahead and do our paint method just for fun. That's interesting. It didn't have a parameter there.
Can I ask you a quick question? If
Yeah.
you've ever run into this problem?
Yeah.
Have you run into the problem where if you go like too fast in the game, it doesn't always catch everything?
Too fast and what?
Like if you're playing the dots game
Ah.
and you fill in like 2 boxes,
Mm-hmm.
go really like if I go slow and like click and then click, then it doesn't have a problem. But on the next game, I could go really fast trying to fill it in to check something, and it like misses a box for an initial.
A lot of times that's just a double click issue. If you try to do 2 lines, well, that might not be. But throw an event handler for a double click and see if that's accidentally firing. That would be one thing. If it's doing enough processing that it misses one of your clicks because you're inside a handler, that would be a little odd. That would sound like maybe you've got something going on in your event handler that might be better handled outside. But yeah, if you can pin down, a use case where that's happening sort of reproducibly, that makes it easier to dig into.
What's the constant keyword in this language?
The constant?
Yeah.
You might try final.
Gotcha.
Basically makes it unchangeable. Let's see. So let's let me just write one more method. We don't need to get X, but let's just do this. So here's a method for getX. Allow caller to read last saved X coordinate. And I'm going to put a tag in here which says @return and say I return the X coord. Alright, so you got your code, right? And as you're writing it, you're putting in these comments. When you are all done with all of that, we can come up here to project and we can say generate JavaDoc. And when we hit that, you may have to fill this in. So if you don't have Java installed on your system, you may need to install Java outside of Eclipse and then just point this to where the JavaDoc command is. It's a standard part of the JDK. So I've got that under user bin, and I'll say finish and yes to all. I don't even know what it asked. And now I've got a new directory underneath, my project called doc. And if I expand that, I've got all these files. And if I click on index, this popped up in a different window. There's the Java documentation for this project, right? So here's the public class main, sample main class for working with swing. There's the author. And all of the stuff that I didn't even know was in there because I'm extending JFrames and so on. There's the constructor, which is main, creates the frame, and there's a static method called main, and I can click on that and come down and see a description of it. And I can also come over to, let's see. Well, that's not really all classes. Oh, I need to generate the JavaDoc in here. Yeah, okay. So now if I look at index, here's a MyPanel class. And it's got some methods, right? There's the getX method, which returns an int. There's paint, save, and so on. And you can click on these and see the details. So getX returns the X coordinate. It overrides getX in this class. It allows the caller to read the last saved X coordinate and so on. So this is documentation with the look and feel of the standard Java documentation that we've been looking at all quarter. And you get it almost for free, right? If you've gotten in the habit of, when you write programming assignments, putting a comment block in front of each method, talking about what it does, what the arguments are, what the return value is, what the side effects are, right? You can keep doing that, right? Just start it with a /*, use these tags inside, and you can say other things like at throws may cause the universe to collapse if x equals 42. And now if I regenerate my JavaDoc, and come back in here and let's look at the save y method. Right, so now it's got this extra tag. Oh, it didn't do it. Oh, that was getX, right? So it's got a separate section in here that also says so overrides what it returns, and it can also throw an exception. And I should have put the name of the exception here. So, but you can describe what the exception is. So this is essentially free, right? And it's less likely people will yell at you about your commenting of your code if you're following, you know, some kind of habit like this, because you're going to produce documentation that has a common look and feel that people are used to expecting. And if you if you just go into your directory tree, so I think we're in the painter class under doc, right? It's just a bunch of HTML files and a style sheet. And so, you know, you can throw this on a web page and index.html if that's sitting in your top level directory of where your web page files are, right? Somebody goes to the web page and bingo, you know, this is what they're going to see is whatever your starting documentation is. So that's something to play with. It's not required, but you know, it's something to keep in mind. Oh, and someone said for C# it's 3 slashes instead of a /** in Visual Studio, so that's cool. All right, so I'm going to leave it there. I have office hours tomorrow, as usual, 7:30 to 8:30. So come by then if you want to go over, you know, questions on anything or PA4 or whatever. I'll get your exams graded and posted over the next few days. And if I don't see you tomorrow, hope you have a great weekend, and I will see everybody on Tuesday. All right.
Thanks a lot.
Thank
Have a
you.
great weekend.
Thanks, you too.